All right. Hi, everyone. My name is Austin Przybysz. Welcome to the Nintendo Hackathon submission. I will be submitting this hackathon in 4 parts. So the first part is the Chainlink operator node pool. The second part is the Fraxis external adapter. The third part is the Brownie Fraxis service, and the fourth is the Avalanche Go node. So let's get started. The first thing we're going to do is deploy the Chainlink node pool cluster in Google. So head over to the GitHub repo and git clone the project submission. Navigate into the Chainlink node pool directory and build the Docker deployment container. We'll enter the container in an interactive shell to set up our cloud environment variables before we apply the Terraform plan for our cluster. There are project directories for on-prem Kubernetes Chainlink node pool deployments and another Terraform plan for Azure, but as of now, the Google implementation is the most built out. Build the container with Docker Compose. Notice how the container is looking for a .env file. You can optionally map in your environment variables like this and skip the first setup step. For now, just touch an empty .env file and execute the setup.shell script with the project ID, project email, and Ethereum WebSocket URL as arguments. This cluster is just going to pass that Ethereum URL into all of the Chainlink nodes. However, to support multiple chains like Avalanche, you would just add a fourth variable here to bring in the connection string to the Terraform plan going forward. Head over to the init plan apply.shell to review the Terraform commands. Terraform init will download all of the Terraform providers required by the plan. Terraform plan will build a manifest of what you are about to apply to Google. The output is useful for monitoring the Terraform state changes in between applying cluster updates. Lastly, Terraform apply will start taking out the resources in the cloud on your behalf. Successfully running the setup.shell script will export the environment variables required by Terraform. This is a secure approach as we ensure these sensitive variables are never published to GitHub. Although, when done, you should save them in a safe place. Please review my notes on the SSH keys that you'll be generating. Once you deploy a cluster, you will need to use the same SSH keys going forward to make amendments or to destroy your cluster later. So save those in a safe place at the very least. Sit tight while the cluster spins up. In the meantime, head over to lens.io to download the Kubernetes IDE that we will be using to manage our cluster. This is completely optional if you know the kubectl commands to navigate the cluster already. Also, go ahead and open your favorite SQL client. You will notice your nodes have been allocated after a few minutes. Click into your cluster in the Google Cloud Console and hit the Connect button. Google will give you the CLI command to generate the kubeconfig file. Execute the CLI command on your local machine for the best results, as Google is quite protective over how the access secrets are managed. If you generate the config file in the cloud, you will have to massage your IAM permissions and also bring down all of your session keys. You could have optionally run the deployment container on your local machine and mounted the kubeconfig directory into your deployment container, thus allowing you to interact with Lens from your container. Lens allows us to scale pod replicas, edit configuration files, port forward services to our local machine, and much more. Notice how when I delete the Chainlink pod, another container immediately spins up. This is because the pod is configured to have 2 replicas running at all times, and Kubernetes will try and maintain the state at all times as well. Open up a Chainlink node operator port by forwarding into one of the services. The API and login credentials are mapped into the container and can be seen by selecting the Chainlink node pod and clicking the API secret to show the actual contents of the secret file. You will use this contents to actually log into the Chainlink node portal. When you first start your cluster, you will notice unhealthy pods. These are remedied by going into the Postgres DB and manually adding a database for Chainlink Binance, Chainlink Coven, Chainlink Avalanche, and Chainlink Avalanche Fuji. There is a setup script in the Postgres deployment to handle multiple database setups, however, it has had to be descoped for time constraints. Select the main Chainlink node pod and open the Secrets tab by selecting API Secret. Copy the email and password. Open the Chainlink node portal by clicking the Port Forward button. After logging into the portal, go ahead and add the bridge for the Fraxis external adapter. You can move to part 2 of the submission now. Copy the example jobs from the GitHub repo into your Chainlink node. Click Run to test. You can review the logs in the pod for the external adapter if you want to watch the API calls come in from your node. Next, we will be exposing data object and Fraxis event APIs from the Fraxis configuration tools. I've opened up a temporary login for a few days that judges can use. So navigate over to sandbox.fraxis.com/API/gateway to see that the API gateway is in fact available. Then go to sandbox.fraxis.com, log in with the temporary credentials, and you can actually review these data objects yourself. I will start by creating an organization and a user, assign that user a role, and then I will start building some data objects. Those data objects are just joins between some logical tables, and those logical table joins will be represented as views over the REST API. Other events in Fraxis can invoke those result sets from the data object. Those data object results can also be piped into other events. Secondly, I'll also be demonstrating how to use the events engine in a sample event where we send in, we invoke a request into the Brownie Chainlink microservice that I deploy in part 3 of this submission. We will just be doing a Hello World example where we listen to a Kafka producer on a specific topic, and then we will be sending messages in from the Chainlink node. The Chainlink node will pass those parameters or that post request into the external adapter. The external adapter will translate that API call into Fraxis and back out to the front. What I'm doing here is just demonstrating how to build an event in Fraxis. You can see I've drug the Chainlink Brownie event out onto the palette, and I'm essentially just configuring a payload and the parameters that Fraxis is going to expect to come in when this event is invoked. I've set NFT and NFT name and head code as the parameters, so the Chainlink node operator will know to pass those parameters along with the action code Chainlink test. Those parameters will get passed into the external adapter. The external adapter will transform that API request into the format that Fraxis is expecting, and Fraxis will resolve that event, return the result set back out to the Chainlink node operator, and from there a smart contract could essentially interact with that result set or transact against it. I have included a Postman collection which contains all of the API calls that you've seen me develop right here. There's an invoices data object, a customers data object, and then 3 billing data objects. There's also an event for the Chainlink test event that I've shown here. That event will just return the initial payload back as it was submitted. However, if you go review the code, you can see how it can easily be modified to inject those parameters into a Brownie process, like pushing a contract or building. And lastly, I just want to demonstrate some of the tests. So I've taken a handful of those examples, and I'm just going to plug them into my jobs and essentially run those, watch those come in through Kubernetes, and you'll see a success message in your Chainlink node operator logs, and that's how you will know that you have completed the circuit and you've sent a API request through the external adapter into Fraxis. Fraxis has responded with a result set, and then that result set will reside in the Chainlink node operator logs. From there, you can pass that into a smart contract or